Hello, I'm Dr. Chuck Higgins from Middle Tennessee State University, and I'd like to just give you a brief overview of the Radio Jove project as we stand in 2014. So just a little bit of history. Radio Jove is named after the Roman god of Jupiter, Jove. And so we like the Jove, sort of like the call signs of a radio station. So Jove is the big red spot on your radio dial. So that's where the name came from, and I credit Jim Tiemann, one of the founders, to with that, giving it that name. So Radio Jove is a hands-on education project, and the goal is simply to get students, teachers, people interested, involved in science and in astronomy. We use radio astronomy as the means to do that. And so by doing that, we encourage people to build their own radio telescope. That's the way to learn, is to do. And so building your own telescope, making scientific observations, and interacting with professionals real time and through an archive, you can learn a lot of astronomy and science. And so we're focused on Jupiter and solar radio astronomy, but that also includes ionospheric work, space physics, space weather. We do have teacher resources, some education materials, so we want teachers and students to be able to use that. And we also have online access to some of our radio observatories, so people can access live data. This is the Radio Jove team circa 2000. So Radio Jove began its planning in 1997 and then sold our first kits in 1999. So we're officially 15 years old. And here is a group of many of the founding members there. Jim Tiemann there on the left would be sort of the overseer, the founder at NASA Goddard Space Flight Center, and many other volunteers, scientists and volunteers. Many of us have the University of Florida connection because of the radio Jupiter astronomy research being done there. And we like to joke that if your name is Jim, you might already be a member of our team. So what is the hardware? Well, our radio telescope, you see, is a simple dual dipole antenna. It's very, very simple, very straightforward, and a receiver that you build yourself. So you put the components on the PC board and wire it up, do the soldering and the testing, and then with an audio cable you can use a computer to digitize the audio signals out of the receiver. So it's a complete system. The antenna poles, the mast, the ropes and stakes, the support structure, that of course is not included with the kit. That you would need that to set it up in your location. But it uses coaxial cable. It's very simple, straightforward equipment to handle and to use by beginners. This is a kind of a schematic of some of the interactions that you can have as a participant. So you would have your own radio telescope, or perhaps you could connect to one of the more professional radio observatories that stream their data. We have software included with the kit that allows you to record your signals and analyze them, and also interact with other radio telescopes and other participants. We have direct contact with some scientists, Jupiter and solar scientists. So that's part of it, that you're able to directly interact with researchers in the field. And so teachers, students can get involved with in the classroom, or perhaps an out of classroom extracurricular activity, a physics club or astronomy club of sorts. So we like to think that we have all these connections with our project. And then, the 15 years that we've been distributing these radio telescope kits, here's a worldwide map. So every country that has at least one Radio Jove or purchased one Radio Jove kit is marked with a red dot here. So we've got over 70 countries that have received Radio Jove kits. So it's quite a worldwide distribution we have. Just a word or two about the software. You're going to hear more about that, in the subsequent talks for the presentations. The key software for Radio Jove is called Radio SkyPipe from Jim Sky, one of the founding members, and you can get the software at radiosky.com, and it's a strip chart. So it's a software program that simulates a strip chart of the intensity of the signal, the strength of the signal as a function of time. And so what you're seeing here happens to be a large and then a small solar burst. That's from Jim Brown and in Pennsylvania. So the interference sometimes will show up, the static interference will show up as these very sharp spikes. The y-axis there is antenna temperature, so you can actually calibrate your system if you choose to do so. What's really clever about this software is that you have the ability, if you have your computer connected to the internet, you have the ability to stream your radio signal live so others can see it. So you can be a publisher of data, or you can also be a client and receive others' data in real time. And so that's particularly good, a good way to compare your radio signals with someone else to kind of confirm something that you received. And there's a fun chat feature in the software as well, that you can chat back and forth anyone that's kind of online. So Radio SkyPipe is our key piece of software. So some of the activities that we do, of course, building your own receiver is an activity in itself, and a great learning experience, learning how to solder and how to identify components and electronics. So, and also building the antenna. So part of that is learning a little bit about radio science, radio waves, and understanding that these radio waves are emitted from Jupiter, the Sun, our galaxy, and certainly plenty of terrestrial sources. So how do you observe those? How do you plan to make an observation? So all that is part of being involved with Radio Jove. And so here's just some examples. SkyPipe traces of what Jovian signals look like, what a solar burst looks like, or what the galactic background. So we're saturated with radio waves from the galaxy, and the background level, this hump that you see in this trace here, shows you when the plane of the Milky Way, the center of the Milky Way, is sort of passing overhead in your nighttime sky. And so you can record and analyze your data using this software. And if you're so inclined, you can actually present some of your own findings at your local astronomy club or even a more scientific conference if you're so inclined. So we target high schools at the high school level. We've had middle schools get involved for sure, but the level of basic science that you need is really at the high school level to get involved. But we've had plenty of colleges, universities be involved, and many interested amateurs. A lot of ham radio people are involved with us because of the familiarity with the type of equipment and systems. The other piece of software that's really useful is called Radio Jupiter Pro. Again, Jim Sky at radiosky.com provides this software for anyone who purchases a Radio Jove kit. And the tool here, the use for this is to allow you to predict when the best time to observe Jupiter is. So Jupiter has you'll hear more about this later, but Jupiter has sort of a cycle of when it emits radio waves, and this software allows you to plan for your location and find the best times to detect radio signals coming from Jupiter. So it's really useful, and I can't recommend it enough in terms of understanding how to be successful observing Jupiter. Also, with your kit, you'll get 2 CDs, and one of the CDs comes with the pro licenses for these 2 pieces of software and some lesson plans, and then most importantly on the Radio Jove CD is the Listening to Jupiter book by Dick Flagg. So Dick Flagg was the inventor of the receiver. So he designed the receiver that we use and wrote this book, second edition now, on how to observe Jupiter, understanding Radio Jove, the antennas, what a solar burst looks like, and even some advanced equipment, advanced hardware. So it's a really useful book for the beginner using radio, doing radio astronomy with Radio Jove. And the other one is an education CD by Dr. Jove Activities, who put together a really fantastic kind of multimedia CD of Jupiter, solar events, audio, visual, a lot of animations there. So it's a great way to kind of introduce yourself to a lot of the basic concepts of Radio Jove, radio astronomy, and Jupiter and solar radio missions. So that's a really nice CD that comes with the kit. We also provide a data archive, so we encourage our participants not only to take their data, maybe do their own analysis, but upload it to our data archive. So if you want to do some science, you want to compare your observations with others, the best thing to do is to put your data on our archive and allow others to look at it and compare it, and maybe discover something. That's part of science, is the serendipity of discovery. So making your records available is a really useful way to do science and to help us do science. So radiojove.org is our data archive there, and so you can upload and download data, and you can see some statistics as of 2014. So we have almost 5,000 records. Well, sorry, actually over 6,000 records in total with images and the SkyPipe files. So we want to keep adding to that, and we want your help to do that. So some more advanced hardware and software that you'll hear about from others this week is the Spectrograph software. So Dick Flagg has also designed a spectrograph, an analog spectrograph system that you can see here in the lower right. So essentially it's a wide band radio antenna, radio receiver, and combined with a wide band radio antenna, you get more channels, more spectra to observe, and we learn more about the Sun or Jupiter when you can look at the spectral signatures. So Jim Sky wrote this Radio Sky spectrograph software, and so that's a real advancement in understanding the emissions coming from Jupiter and the Sun. So this is, it's more expensive equipment, so you really it's a level up in terms of cost and investment and learning. But starting with the basic Radio Jove kit, which is just a couple $100, is a great way to start. And then if you're inclined, you can get interested in this more advanced equipment later. Some of our projects, we are studying the long-term trends of the Jovian radio missions. So Jupiter radio signals were discovered in the mid-1950s, and so we are collecting data and plotting data on an occurrence probability map that you see in the upper right. This is from Dave Topinski in Florida, and what's plotted here are observations, detections of Jovian radio emissions as a function of Io's location and its orbit, so that's the y-axis here, and Jupiter's longitude as the x-axis. So we can learn something about where the emissions are coming from, how the emissions are generated, and some gives us more understanding about the Jovian magnetic field, the Io Jupiter system and interaction. So the more data we collect and add to this map, the better the resolution, the better we can understand what's happening at Jupiter. And we also have a project to detect solar bursts and plot those as a function of time. So monthly solar radio burst averages now these are at 20 megahertz with Radio Jove equipment, and to track it like you would track sunspot numbers. So what could the radio emissions tell us long term in terms of solar cycle or otherwise? So this is a plot of many years. Kind of unfortunately during a minimum here in 2007, 8, and 9, but we're on the uptick now to the next solar maximum. So we're going to keep adding to that graph. Some of our more scientific data, those that have calibrated their systems, we can actually do science with it. And so we are taking some of those data records, and NASA is putting them and connecting to those through their virtual wave observatory in this case, for heliophysics data. So some of our solar data might be useful, and so we are going to work with the folks at the virtual wave observatory to make our data easily accessible for them. And so in summary, we have a lot of talks, a lot of information to give you this week. We have 15 years now of Radio Jove experience, and we've improved things quite a bit. And ultimately, we want people to learn and do their own radio astronomy. And so, with the Radio Jove telescope system at a reasonable cost, you can have your own radio telescope, and you can collect your own data, share it, and contribute to scientific contributions, and hopefully learn and grow with us as we develop new tools and improve our data. And we are going to collaborate with the Juno mission to Jupiter, and so we can provide some ground-based observations while the Juno mission orbits Jupiter and makes near-field observations of Jovian radio emissions. So thank you very much. Happy to have you interested in Radio Jove, and certainly reach out to any of us on Radio Jove team if you have questions. Thank you very much, and have a good week. Have a good conference.